Welcome. We are here today to talk about some percent composition. So we'll essentially be looking at what elements are in compounds and how much of those elements are in compounds. We're going to be using some of that molar mass, so you might want to have a periodic table handy. So as we start talking about percent composition, this is something that you probably encounter every day and you don't even realize it. Some of the places you might see this are in fertilizers. I know that we have some farmers out there, but when we put fertilizers into the fields or even just into a garden, there's always these numbers here. The NPK, nitrogen, phosphorus, and potassium are the elements that we put into our gardens. And there's a percent composition that we look for depending on what the needs are of the field or the garden. You see it in food, in the nutrition facts. We have percent daily values here, and we also have the amounts of what are in the food. We could figure out what the percent composition is. You would even see it when you breathe, because there is a percent composition of oxygen in our atmosphere, about 21%. But most of the air we breathe is nitrogen, about 78%. So all percent composition is just the relative amounts of elements in a compound. And we take this using the mass of an element, the percent by mass of an element in the compound. So to figure this out, if you think back to any of the other percents that you've ever found, all it is the part that you're looking at divided by the whole thing. So in this case, we'll be looking at the specific element, that's our part, divided by the mass of the compound, or what it's in. So if we take that divided by the other times 100, that's going to give us the mass of the element. Each one of these is in mass, so these are going to be a grams over grams. So if we were to do an example of this, what is the percent composition of all the elements in NaNO3? Well, to start out, we kind of need to know what each of those individual elements are. So we would use their molar mass, and then we would take the mass of that element divided by the whole thing. So we take our Na, and on our periodic table, Na has a molar mass of 23 grams. Nitrogen has a molar mass of 14 grams, and oxygen has a molar mass of 16 grams per mole. And we have 3 of them. So we look up each of these molar masses, and we add them up so that we know what the total molar mass is for that compound. Then we can find the percent composition of each of these elements within this compound just by dividing. Again, we take our part that we're looking at divided by the whole thing. So part for Na would be 23 divided by 85 times 100. So 27% of this compound by mass is sodium. 14 divided by 85, or our part divided by our whole, times 100 gives us 16.5%. So only 16% by mass is nitrogen in this compound. And 48 divided by 85 times 100 gives us 56.5. So over half of this compound is made up of oxygen. Now sometimes we won't just want to find it in a compound. That really doesn't do us a whole lot of good because usually we're working with a specific amount of mass. So if we want to find the mass of an element within a sample, say I'm given 15 grams of water and I want to know how much of that is oxygen, I have 2 steps this time. I do the same thing that I just did, I have to find the percent composition within the compound, and then I can use that percent to find the mass in the specific quantity. So if I had a hydrogen sample, or if I wanted to know the mass of hydrogen in a 40-gram sample of water, okay, say I was going to use electrolysis, and I was going to split the water in half, and I wanted to know how much hydrogen I would get out of that. Well, I can find the percent composition of water in general just using the molar mass, just like what we just did. So I would take the molar mass of each element. Hydrogen, from our periodic table, has a molar mass of 1 gram per mole. There are 2 of them, so total would be 2. Oxygen is 16, so total water has a molar mass of 18. In every water, no matter what it is, no matter if it's in a 40-gram sample or a 100-gram sample or a 1,000,000-gram sample, water is all the same. 11% of it is going to be hydrogen, because 2 divided by 18, or our part divided by our whole, times 100 is 11. 16 divided by 18, or our molar mass of oxygen divided by water, times 100 is 88%. So no matter what the sample is, 11% is always going to be hydrogen, and 88% is always going to be oxygen. So we can now use that percent from that step to find the mass in that quantity. So if we're looking at just hydrogen, we're essentially looking for 11.1% of 40 grams. So 11.1% of 40 grams, we can move this decimal 2 places to put it into a fraction and take 0.11 times 40 to get 4.1 or 4.44 grams of hydrogen in that sample. So out of 40 grams, most of it's oxygen, but this amount would be hydrogen. All right, if you have any questions, let me know. Feel free to come in the morning after school or email me, and we will practice this a little bit more in class next time. Signing out.